Hi Katie, thanks for sending some more questions. So I see that we're going to be solving 34 and 35. Let's go ahead and take a look at 34 first. That's going to be the easier problem. It's just going to involve some simple factoring. So the very first thing we want to look at when we're solving an algebraic equation or a quadratic expression is whether we can factor out any monomials, any single terms. It looks like between these two terms, they both share an x in common. And x squared certainly has an x in it, and this 9x also has an x in it. So let's go ahead and factor out an x. And after we've factored out that x, we'll put what's left in these parentheses. After you factor out an x from x squared, you're just left with x. And after you factor out an x from negative 9x, well, you're just left with negative 9. That, of course, is still equal to 0. Now, once we have this factored, we can take each of these factors and set them equal to 0, and that's going to give us the solutions to our equation. So we'll set our first factor x equal to 0, and then we'll set our second factor, x minus 9, equal to 0. X equal to 0, nothing to do there. That's going to be one of our solutions. For this one, we just need to do a little arithmetic. Let's go ahead and add 9 to both sides. And we'll be left with x on the left-hand side and 9 on the right-hand side. So this is going to be the second solution to our problem. So your set of solutions to this problem are going to be x equals 0 and x equals 9. So it looks like that's going to be B. Now let's go ahead and take a look at number 35. It's a little bit more complicated, but I know you can do it. So the first thing I noticed about number 35 was we got some really big numbers floating around in this quadratic equation. And these numbers have other numbers in common, meaning we can factor stuff out. 40, 76, and 28 all share a factor of 4. So let's go ahead and factor out that 4 and rewrite this quadratic equation in here as something that's a little nicer to look at. If you factor out a 4 from 40x squared, what we're going to be left with is 10x squared. Factoring out a 4 from negative 76x, we're going to be left with negative 19x. I had to get out my calculator to do that problem, so please use that as well if you need it. Factoring out a 4 from 28, we are going to be left with a positive 7, and of course that is still equal to 0. So now we're looking at this quadratic equation, which is going to be a little easier to solve. I'm going to solve it using one of my favorite methods because you can apply it in any case. And it's especially helpful when you have these numbers in front of these x squared terms that are not 1. Things can get tricky. It's called the star method. Let me go ahead and outline that for you. So you're just going to draw an x and then a horizontal line. Up in this first triangle, we're going to be taking the first number and we're going to be multiplying that by the last number. Down in this bottom triangle, we're going to be putting our second number. Our second number is the number in front of the x term. The first number is the number in front of the x squared term, and the last number is just your constant on the end. In these triangles on the side, we're just going to be putting our first number. And down here, we're going to be putting some factors. I'll explain more about what that means as we work through this. So let's go ahead and apply the star method to our problem and see how that works out. So we'll draw a star for our problem. And let's go ahead and pick off the first number, which is going to be a 10, and then the last number, which is going to be a 7, and we multiply those together. So 10 times 7 is 70, That's the number I'm putting in the top triangle. The second number, just pick that off. It's right in front of the x term. If there's a minus sign in front of it, make sure and include that. That's part of the number as well. So we're going to have a negative 19 down here. The first number is just the number, once again, in front of the x squared term. So we're going to be putting 10s over here and a 10 over here. So our factors come when we find two numbers that multiply to 70 and add to negative 19. To help us do that, since we have some big numbers, I'm going to go ahead and draw a factor tree for 70. So the easiest numbers that I can think of that multiply to 70 would be 7 and 10 then breaks down again into 5 and 2. So let's try, it's kind of trial and error. Let's try 7 and 10, and then we know that we're multiplying to a positive number but adding to a negative number. So both of these numbers would have to be negative when we add them. So both of these numbers, negative 7 and negative 10, do indeed add to multiply to 70, but when we add them together, it looks like they add to negative 17, not negative 19. So that's the wrong number. Let's look at our factor tree and see if we can figure out something else. Well, we know 5, 7, and 2 add to 70. So maybe if we mix it up in a different way. 7 times 2 is 14. Perhaps if we multiply 14 by 5, that will multiply to 70, and maybe it will multiply or add to negative 19. So we know that 14, 7 times 2, times 5 multiplies to 70. Since they have to add to a negative number, they both have to be negative. And when you add negative 14 and negative 5, you do indeed get negative 19. So it looks like these are the factors that we're looking for. So we're going to go ahead and put those in these bottom triangles. I'm going to go ahead and put the negative 14 over here and the negative 5 over here. It doesn't really matter which side you put them on. So once you've got your factors, we're done with the top and bottom triangles, and we're just going to be looking at these pieces right here. I want you to look at them as if they were fractions, because if these were fractions, we'd be able to reduce them, and that's exactly what we're going to do. If I had 10 over negative 14 as a fraction, I would reduce that to 5 over negative 7. I'm going to keep that negative on the bottom because that's where it was before. That's very important. If I had 10 over negative 5 as a fraction, I would reduce that to 2 over negative 1. Again, keeping that negative on the bottom because that's where it was before. So I'm going to put an X next to the number on the top once we're done reducing. There's my little X over there if you can see it. And then instead of writing these numbers horizontally, or writing them vertically, we're going to write them horizontally. So we still have this 4, but now this expression of 10x squared minus 19x plus 7 has factored into, let's take our first factor, 5x minus 7. Easy peasy. Now we have our second factor, 2x, and it looks like this is also negative, so we're going to have minus 1. And of course that's still equal to 0. So now that we have this entire expression factored, it's going to make it much easier to solve. We have three factors, 4, 5x minus 7, and 2x minus 1. We're going to set them all equal to 0. 4 equals 0 is nonsensical, so that's not going to yield us any solutions. Let's move to the second factor and set that one equal to 0. 5x minus 7 is equal to 0. We can add 7 to both sides. And we get 5x is equal to 7. We can then divide both sides by 5. That's going to cancel out on that side. And we get x is equal to 7/5. That is our solution that comes from this factor. Now let's go ahead and work on this factor and set that equal to 0. So 2x minus 1 is equal to 0. Again, that's coming from this factor right here. We're going to add 1 to both sides. And we end up with 2x on the left-hand side and 1 on the right-hand side. And then we're going to go ahead and divide both sides by 2. This is going to cancel out on the left-hand side. And what we end up with is x is equal to 1/2. So it looks like we have two solutions to this equation. The first one, x equals 7/5, and the next one, x equals 1/2. Let's go ahead and take a look at your solutions. And it looks like 1/5 or 1/2 and 7/5 are indeed possible answers. So B would be the correct answer in this case. Thanks again for your questions, Katie, and I look forward to answering more of your questions using SnapMath in the future.